Good morning, students. I am Dr. Verma from ADARSH MANDIR. Students, today we will discuss some important topic of P block elements. So today I will discuss about 15 group. Now you know in 15 group there are following elements. These are nitrogen, phosphorus, arsenic, antimony, bismuth. Actually, these all elements belong to nitrogen family because the first member is what? Nitrogen. And the general electronic configuration for this group is NH2 and P3. So there are 5 electrons. If we see the first member, that is nitrogen, nitrogen show anomalous behavior. It means some different behavior other than these members like phosphorus, arsenic, antimony and bismuth. The reason of the anomalous behavior is due to the small size of nitrogen, high electronegativity and due to the absence of d orbital. Now one question is generally asked that the phosphorus form PCl3 and PCl5 both, but nitrogen only form NCl3, not NCl5. So what is the answer of that? You know that there is no d orbital in nitrogen, so nitrogen cannot extend its valency. There are only got s and p orbital, so due to absence of d orbital it only forms what? NCl3, not NCl5. That is the answer of that question. Okay, so actually N can make maximum 4 bonds, 3 covalent and 1 coordinate. We have seen ammonia. In ammonia molecule, you have 3 covalent bond and there is 1 lone pair on the nitrogen. Okay. So today we will discuss about the hydrides of this group elements. So actually you know the valency, general valency is what? The valency is 3 because there are 3 electrons here and P3 you can see. But in case of phosphorus, due to presence of d orbital, it can form 3 and 5 bond also. So for phosphorus, PCl3 and PCl5 both are. So according to its valency, when these elements actually react with the hydrogen, they form hydrides. So what is the general formula? That is, I have written this reaction. Suppose X is the element of this group and that is hydrogen. So when hydrogen react with the X or the element which belongs to 15 group, so the hydride XH3 is formed. So we can write the formulas of the hydrides. For nitrogen it is NH3, for phosphorus it is EH3, that is ammonia, that is phosphine. For arsenic that is ASH3, arsine, and for antimony that is SPH3, and for bismuth it is AS3. These are the formula of the hydrides of these members or the element of this group. Now we will see some properties of these hydrides. If you see the ammonia, actually you know what is the type of hydration? You know there are 3 bond pair and 1 lone pair. There is 1 lone pair. So actually the hybrid is what? It is nitrogen sp3 hybrid and the shape is pyramidal. There is 1 lone pair to show due to the presence of 1 lone pair, the shape is pyramidal, that is distorted. Okay, it is not tetrahedral. And one more thing is there, due to presence of this lone pair, ammonia act as what? Lewis base. They are bases actually. They can act as what? Base. Now, first property I have just taken it as stability of these hydrides. So actually when we move from top to bottom, from what? NH3 to BiH3, so the stability decreases. Why? Because as we move downward, so you can see that there is increase in the size of the atom. Nitrogen, then phosphorus, then arsenic, antimony, bismuth. So due to increasing the size of the atom, the bond length also increases. If you see this bond length, that is NH or BH or ASH or BAH or and SBH. So the bond length increases. So what will happen? The bond energy will decrease and the bond is easily broken down. So the stability is is what? Decreasing from top to bottom. Now next point, bond angle. So as we move from top to bottom, so you can see that there is decrease in the bond angle. In case of ammonia, you know, bond angle is around 107, and that is less than the water. The tetrahedral angle, due to presence of one lone pair, you know, there is bond pair lone pair repulsion. According to VSEPR, we can explain. So actually, as we go downward, so actually the bond angle is decreasing. Why? Because if you see the electronegativity, so the atomic size increasing, so what will happen? The electronegativity decreases. So due to decrease in electronegativity, the bond angle also decreases. Okay. Now next point is boiling point. You all know that boiling point or melting point, they are proportional to molecular mass. As molecular mass increases, the boiling point and melting point also increases. So according to that concept, if we see, if we move from NST to VIST, so there is increase in the atomic number, so the atomic mass, or you can say the molecular mass also increases. But so according to that, it means what? There should be increase in the boiling point. But exceptionally, if we see, okay, SPAC and ASC, they have the high molecular mass, so they have high melting point. But if you see exceptionally the ammonia, it has more boiling point than PSC and SH3. Why? Because in ammonia there is H bonding. You know, ammonia can form intermolecular H bond. So due to the intermolecular H bond between ammonia molecules, they are bonded actually. So high amount of energy is required to separate them. So due to presence of intermolecular H bond, the boiling point of ammonia is high. So on the basis of that point, you may have question why ammonia show the high boiling point and other hydrides. So the answer is what? Intermolecular H bonding. Okay. Now next, basicity. Actually, you know, these are hydrides, and in this case, the basicity is what? Decreasing from what? Top to bottom. It means the basicity, actually here tendency to give the lone pair. So actually nitrogen has a small size. So in a small size there is more electron. So the electron density of nitrogen in NH3 is high. Okay, so it is having more electron density, so it can donate the lone pair easily. So the basicity of ammonia is what? High. And further as we move from ammonia to VIST, the basicity is decreasing. So you can be asked why the basicity of ammonia is greater than the PSC. So you can explain on the basis of the size of atom. Due to smaller size and high electron density, you can say the ammonia is what? More basic. Now next, reducing power. Actually here reducing power means what? The tendency to give what? H atoms or release H. So you know, actually here reducing power increases from NH3 to VIST, because the bond length, you can see the bond length increases. So bond length increases, so when bond length decreases, and in VIST, due to high bond length, it will easily release the H atom. So the reducing power increases. Okay, so just prepare this points for hydrides. Now there are some compounds we have in that. First one is dinitrogen, that is N2, and the second is ammonia, that is NH3, and third is nitric acid, that is HNO3. How can we prepare the dinitrogen? You see, in laboratory we can prepare the dinitrogen by the reaction of what? Ammonium chloride and sodium nitrite. So when we treat NH4Cl with NN2, so you know NaCl is formed and NH4, ammonium nitrite is formed. Further, ammonium nitrite is decomposed to give dinitrogen and water. So that is the laboratory method of preparation of dinitrogen. Second, we can also have the dinitrogen by the heating of what? Barium azide. That is BaN3 whole twice, barium azide. So when we heat the barium azide or sodium azide, we have our nitrogen gas. Okay, you can see this reaction. BaN3 whole twice on heating gives barium plus 2H2 dinitrogen gas. Now one question is asked why dinitrogen is less reactive. So if you see the bond, number of bonds, so the bond range is what? 3 for N2. So the bond dissociation energy is what? High. so it is less reactive. So nitric is also used in bulk due to its less reactive nature. Now next, second, ammonia. There is one well-known method, that is Haber process of formation of ammonia. So you know, in that we treat the nitrogen gas with hydrogen and ammonia is formed. That is N2 plus CH2 gives 2NH3 in presence of iron or molybdenum, that is catalyst. Or we can use alumina Al2O3 or potassium oxide K2O or FeO as a catalyst. Now it is exothermic reaction. So in this exothermic reaction, you know, according to Nitric principle, as it is exothermic, so less temperature and high pressure is required. So here the required temperature is what? 773 Kelvin and pressure is 200 into 10 to 5 Pascal. That much of pressure is required for the formation of ammonia. Now next is nitric acid. So for nitric acid, there is one industrial method, that is Ostwald method of formation of nitric acid. In this method, actually, we treat first ammonia with oxygen to form nitric oxide. The reaction is 4NH3 plus 5O2 in presence of platinum catalyst, 4NO plus 6H2. It means nitric oxide, that is NO, is formed. Further, this nitric oxide is oxidized to give you nitrogen dioxide. 2NO plus O2 gives 2NO2. When this NO2 react with water, or is treated with water, so nitric acid is formed along with nitric oxide. So 3NO2 plus H2 gives 2HNO3 plus 2NO. So that is the method of preparation of Ostwald method of preparation of what? Nitric acid. Topics finished. Thank you.